Kia ora, here are 3 slightly harder questions from Delta. Still working on how we use surds. So the first bracket that we're going to expand here will give us 3 times root 10 x cubed y cubed. Okay, so I'm just basically gathering up my x's, my y's, and my numbers. Now I have, well, 3 times root 5 x squared y times negative root 5 x squared y will give me 3 times just what's under the bracket, 5x squared y. So that bit's going to be fairly straightforward. Now the convention when I've got an odd numbered power is to think of this expression like this. So the x cubed you can think of as x squared times x, y squared times y. Now we're not going to do this after about the first time, but that's really what we're saying, is that we're splitting out the x cubed into the highest possible even numbered power inside, which here is x squared and an x. So we can now take a square root of x squared and a square root of y squared, and we write that out the front. So we get 3xy root 10xy minus 15x squared y. Okay, next one. Right, we're going to expand this out using FOIL. So first terms we get 2 root x times x is 2x. Then plus 3 root xy minus 2 root xy, and lastly the outer ones, minus 3 times root y, which is 3y. Now we can collect up the 2 terms in the middle. We get 2x minus 3y plus 1 root xy. Next question. Okay, this is a squared expression, so I'm going to write it out the long way. Oh, this is a bit tedious, isn't it? Right, so I think it's safest to do this when you're doing your working. If you're very confident, you can skip this step, but it's so easy to make a mistake when you do that. So I would do it this way, at least to start with, and take a good look. So we're going to do FOIL again, and that first term simplifies or expands to 4 times a squared plus b squared. So that's very nice. The outer terms, I get minus 6. Let's have a look at this. We've got a squared plus b squared times a squared minus b squared. Right, so you might already be spotting that there's a difference of 2 squares pattern in there, which is going to be lovely. And then we've got that again. Right, so now we've done the first ones, we've done the outsides, now we're doing the inner ones. So we're getting minus 6 times a squared minus b squared, a squared plus b squared. And then the last one, the outer terms, will be minus 6 a squared minus b squared. Right, so I really hope that you're writing this down as you go, because just watching this one is not going to help you learn it. So now obviously we've got to do some more simplifying and some collecting up like terms, but it's going to simplify down quite nicely. So make sure you've got that line copied down, because I'm going to start from there on the next slide. Alright, so when I expand that first bracket, I get 4a squared plus 4b squared. I'm going to look now at that easy last term, which will give me a plus 9a squared minus 9b squared. And I've got minus 12 a squared plus b squared, a squared minus b squared. Close bracket. Now let's look at what we've got going on in that term there. Well, I've got a difference of two squares, right? A squared plus b squared, a squared minus b squared. When we first saw a difference of two squares, it always had a pattern like this one. So you've got to get good at spotting that pattern. Right, so we'll collect up the first bit on the way. We've got 13a squared minus 5b squared minus 12 root a to the power of 4 minus b to the power of 4. Okay, make sure you can see where that came from. You're just going a squared times a squared. That sum, so that's that product, b squared a squared there, minus b squared a squared there. They go. Minus b to the power of 4. So that's as far as we can simplify this last question. Don't want to see anyone doing this. Okay, because we know that that is not true. So don't be tempted to try and take it any further. So your final answer here, 13a squared minus 5b squared minus 12 root a to the 4 minus b to the 4. Thanks for watching.